Is the plane side visible now? Plugging of induction motor title.
Yes, sir.
Okay. So now we have seen how the motor starts. Okay, that is by giving the three-phase supply to the stator, it will create RMF. The RMF will induce EMF and currents in the rotor. Then the rotor will produce the torque. The motor starts. Now, how to stop the motor or reverse the direction? In many applications, I have to run the motor in bidirectional mode. The best example what I gave you is lift. Okay, for every up and down operation of the lift, my motor should operate in reverse direction. Then how to do that? One thing we know that the direction of rotation of the motor is along the direction of RMF. If the rotating magnetic field is in clockwise, okay, then my rotor will also rotate in clockwise. Okay, if RMF produced, okay, if suppose RMF is in clockwise, then my rotor will also rotate in clockwise. If RMF is anti-clockwise, rotor will also rotate in anti-clockwise. So to control the direction of or to change the direction of rotor, I simply has to change the direction of RMF. The moment RMF reverses, the rotor will reverse its direction of operation. Then how to reverse the direction of RMF? Okay, so here what one thing it is motor or rather than motor, you can say rotor. Rotor runs in the direction of RMF. Rotating magnetic field. Okay, now if RMF is reversed, if RMF is reversed in direction,
So screen is not visible.
still it is not visible.
Yes.
No, sir.
Sir, it's actually visible. I think they have to pin the screen from the.
No. There is some issue here even at my end also. It is not showing that there is a screen sharing happening.
But I can see your screen.
You can see.
No,
Just
sir, we can't, sir.
no, just a moment. I will log out and log in again. Now is it visible?
Yes, sir.
Yes, sir.
Yeah. Okay. So if RMF is reversed in a direction, if RMF is reversed in direction, then rotor also rotates in opposite direction. In opposite direction. Now this way of reversing direction of RMF is not only used to reverse the direction, but also to stop the motor suddenly. Now tell me one thing, when you are running with some speed, okay, when you are running with a very large speed, can you reverse your direction of run suddenly?
No.
Or can you stop yourself suddenly? At the same point, you should not move after that point.
No.
It is not possible for every or any body, not only anybody, any body, whatever may be the type of body it is, when it is moving in one particular direction at a certain speed, if the speed is large, then stopping it at a single point is very difficult at the same speed. If I want to stop, we all ride our vehicles. Okay. So when I know that I have to stop at some particular point, what we will do? When we get to know that we are approaching that point where I have to stop, I reduce my speed. Right?
Yes.
Now, if I don't know that suddenly somebody else will come into the road, which I don't know, accidents happen the same way, right? Why accidents happen? Because at a certain speed, when the vehicle is moving, if sudden obstruction will come, then the driver will not make out that obstruction. He cannot stop the vehicle at that point. So because of that, the vehicle will go and bang the opposite vehicle or opposite person or opposite whatever the obstruction is. Why this is happening physically? Because the moment of inertia is very large. You cannot make it suddenly zero, right? Whatever the kinetic energy the body has gained during its running time, it cannot be dissipated suddenly to another body or outside, or it cannot be lost immediately, because of which the bang will happen. What happens as a result? There is a mechanical damage occurring to the body, whether it is a car, whether it is a person, whether it is an object, whether it is whatever. When sudden stopping will happen of any moving body, there is a mechanical damage bound to occur at a large speed. Now what will happen here? Okay, now what will happen here? When I want to stop the motor suddenly, or at a particular position, or at a particular point, then one thing is I will switch off the supply. Okay, I will just disconnect the stator from the supply. Motor will stop eventually, but motor will not stop immediately because of moment of inertia gained. It will take some time to come to halt. Is it?
Yes.
Now, if the direction of the motor has to be reversed immediately, then I have to reverse the direction of RMF immediately. In that case, what happens? We will look into here. Okay. So when the induction motor has to be quickly stopped, then what I will do? I will, for a moment of time, I will give the opposite direction to the rotor. How do I get opposite direction to the rotor? I will give opposite direction for RMF. How do I get opposite direction of RMF? By interchanging any two phase. Okay, when a phase sequence is changed, when a phase sequence of supply is changed, what is phase sequence?
RYV.
Phase sequence means what? It is the order in which the phase values of voltages appear. Suppose the three phases are R, Y, and B. RYB is, if I say, is a phase sequence, then R will be at omega t equal to 0, Y will be at omega t equal to 120, and B will be at omega t equal to 240. If I say the phase sequence as RBY, then R will be at omega t equal to 0. Starting phase angle of R is omega t equal to 0. Starting phase angle of B is 120. Starting phase angle of Y is 240. So that is called phase sequence. Now when a phase sequence of supply is changed, when the phase sequence of supply is changed, the direction of RMF is reversed. Only once I have to do. The direction of RMF is reversed. Okay. So how do I change the phase sequence? That is by interchanging any two lines. That is by interchanging any two lines. Okay, that is, if RYB is initial phase sequence. Then if I give RBY, then it will RMF is reversed. This RMF is reversed. Okay. Now when RMF is reversed, rotor is reversed. Now if I have to suddenly, okay, if motor has to be stopped quickly, if motor has to be stopped quickly, then any two lines of supply can be interchanged. Can be interchanged. Okay. Now with this, what happens? Suddenly the RMF reverses. To reverse RMF, there is no time required because RMF is a flux. RMF will suddenly reverses. But because rotor is a mechanical body having some mass, okay, it will take some time to reverse itself. So what is actually happening here? Is it like, am I applying brakes to the wheels of my vehicle? Yes.
Yes, sir.
How do I apply brakes to the wheels? Mechanically, either I will be having the disc or I will be having the drum. So what is happening with the disc and drum, or especially in drum? A brake pad will go and brush with the rotating body of the wheel, and because of the friction, the speed stops. In disc, what will happen? Disc brake, there is a claw-like structure which will be holding the disc suddenly, and the rotating body stops almost immediately. In drum, it will not happen immediately. In drum, it will brush. It will take some time to stop. But whereas in disc, it will stop immediately because I am directly obstructing. Is it the same I am doing with the rotor now? The rotor is rotating, suppose in clockwise direction. When I change the phase sequence of the supply, it tries to go back immediately in the opposite direction. So in that moment, it has to stop its forward motion. Okay, it has to stop its forward motion, come to rest for a moment, then start its reverse motion. Am I applying the brakes here now to the motor?
Yes.
Okay, so this method of interchanging supply lines, okay, is called plugging or breaking. Breaking, not breaking. Brake, applying brakes. Plugging or breaking of induction motor. In many applications, we need this. Especially this we need in our electric vehicles because I have to stop. Okay. Now, during this period, okay, during this period, motor acts like brake. During this period, motor acts like brake. Motor acts as brake. Okay, motor acts as brake. Okay, or motor is in braking mode. Motor is in braking mode. So earlier motor was in motoring mode. Now motor is in braking mode. Now what will happen to the power that is delivered to the rotor and developed by the rotor? Yes. The power is, see, when the rotor is rotating, it is developing some power, right? Now, the moment I applied the braking, that is the moment I plugged the motor or I interchanged the supply lines, the rotor has already developed some amount of gross power PM. What happens to that power? Now, that power PM is developed by the rotor to rotate in one direction. Okay. But that power is not utilized now by the rotor to rotate in that direction. Now it has to, that power has to be completely thrown out of the motor. Is it right? The power that is developed by the rotor in its forward motion. Suppose first I take forward motion. The power that is developed by the rotor in its forward motion, when the braking is applied, the power developed by the rotor should be thrown out. How it will throw out? It will throw out that power in the form of heat dissipation. Okay, so you can say okay. Now why this power is developed? Remember one thing, this is an induction motor. Okay, now here I have connected this induction motor to a load, whatever may be the load. Okay. A load. Now load is also rotating, motor is also rotating. Now what happened? Instead of RYB, I have given RBY. Now the direction has been tried to be reversed only in the motor section. But what happened to the load here? Load is rotating in one direction. Suppose the load is rotating in clockwise, motor is obviously rotating in clockwise. But at a particular moment at t equal to t naught, the motor is been tried to reverse in its direction. Now the motor is getting reversed operation, but the load is still rotating in the same direction. Because the power that is developed here in the rotor has to be transferred to load. Okay, so before the reverse power developed by the rotor is transferred to load, the load is still trying to rotate in forward direction only. Because of which, but now what had happened? The rotor suppose has stopped immediately after the plugging has done. Now the rotor has stopped, but the load is rotating. It means that the rotor is now receiving external mechanical energy to it. The rotor is now receiving external mechanical energy or kinetic energy to it. So this rotor will absorb the kinetic energy and dissipate in the form of heat. Okay. The rotor will absorb the kinetic energy and dissipate in the form of heat. Okay. Along with this, the motor already had developed some power before the plugging. Before plugging, the motor has developed the power. That power is not yet transferred to the load, but the plugging has happened. Now that power which is developed by the rotor is also thrown out in the form of heat. Okay. So how it is thrown in the form of heat? It is thrown in the form of heat due to rotor copper losses. There is no any other way. There is no any other way. For a moment when the rotor is stopped because of plugging, the rotor is a short circuited secondary of a transformer. A large short circuit current will flow the moment a motor stops because slip become 1. Okay. A large current will flow in the rotor. That large current is not developing any torque. that large current is not developing any torque, but it is completely getting wasted against the resistance of the winding or the rotor bars, and that is dissipated in the form of heat. And sometimes this current may be much larger than the short circuit current during the start. Okay, so we should be careful enough while plugging the induction motor. Okay, while if I am using induction motor with plugging operation, then the current handling capacity of the rotor conductors must be oversized. That care we should be taking. Okay. Now next, the power developed in rotor, that is PM, is dissipated as heat. Is dissipated as heat. Okay. Now, the rotor developed power is dissipated as heat, but I haven't cut off the supply. Only the phase sequence of the supply is changed. So even when the motor is under braking operation, the motor is still receiving the power from the stator. The rotor is still receiving the power from the stator. That power received by the stator is also dissipated in the form of heat. Okay, so there are three powers which are dissipated in the form of heat. One power that is developed by the rotor itself. Second power received by the load because of kinetic energy. Third power received by the stator before it starts operating in the opposite direction. So when the motor stops for a moment when plugged, then the phase sequence is reversed. At that particular moment when the motor is at standstill, it is dissipating three powers in the form of heat. And this temperature rise may cause, this heat dissipation may cause a large temperature rise in the motor. Though it is momentary, but it will cause large temperature rise. So the insulation that we use in the motor should be good quality insulation that should be capable of withstanding this momentary increase in the temperature. So only whenever I am choosing a motor, first I should choose for what application I am choosing a motor. Not all the motors are useful for everywhere. Okay. Now, so this is one thing. Even when motor is stopped, due to plugging, am I audible? Na? Connection is intact.
Yes.
Yes, sir.
Even when the motor is stopped due to plugging, rotor continues to receive power. Rotor continues to receive power. Okay? P2 from stator. We will see what PM, P2 and all in power flow diagram. P2 from stator. And it is also dissipated as heat. Heat by rotor. Okay, it is also dissipated in the form of heat by the rotor. Okay, so as a result, what will happen? And all these are in the form of I square R losses only. Okay, above heat dissipation is in the form of I square R losses. because rotor is short circuited, therefore current is very large. Okay. So as a result, uh, plugging produces large copper losses, large rotor copper losses specifically. Large rotor copper losses. So we should be careful enough when we are plugging the induction motor about these losses. Okay, because as a result of loss, we will lose insulation. If insulation is lost, stability of the machine is lost. Insulation is the most important part of any electrical system, but insulation is the most weakest part of any electrical system. Okay, this is all about plugging induction motor. Now, so far this point, we have seen the motor operating as a motor. Now we have seen the motor operating as a brake, or this is the braking mode of motor. And remember one thing you just see, it happens for a moment. When I apply plugging, when I do plugging, I told that the motor stops, but kinetic energy flow is from load. Is it? The load has not yet stopped because load has gained some kinetic energy because of its moment of inertia. Okay. So load has gained some energy because of its moment of inertia. So when the motor stops, the load is still rotating because of its MI, that is moment of inertia. Now that rotation is now fed back into the rotor of the induction motor in the form of kinetic energy. Now is it acting as a generator? There is a three-phase flux. There is kinetic energy input to the motor, though it is momentary. Is it acting as a generator?
Yes.
Is the power regenerated into the motor?
Yes, sir.
So this kind of braking is known as regenerative braking, which extensively are used in all electrical vehicles. Okay. Since kinetic energy is flowing from load to rotor, okay, because load has moment of inertia. Since kinetic energy is flowing from load to rotor, a regenerating action is happening. A regenerating of power is occurring. Regenerating of power is occurring. Thus, plugging is also known as regenerative braking. Is also known as regenerative braking. Okay, so you just imagine an electric vehicle on the road. You take a normal vehicle on the road. How many times do I apply brakes? More than changing my gear, I apply brakes on the Bangalore roads. Is it? Yes or no?
Yes.
What is happening in an electric vehicle when the brake is applied? Suppose the motor is a DC motor. Plugging is there in the DC motor also. It means reversing the supply terminals. If positive to negative, negative to positive is reversed, the motor will start rotating in opposite direction. Okay. Now suppose I have a DC motor here having say two terminals X and Y. Now if I give positive supply to X and negative supply to Y, then if it rotates in clockwise, and if I change the direction of the supply, it will rotate in anti-clockwise. So plugging can be done even in the DC motors, which you will study in industrial drives in 8th semester. Plugging can be done in DC motors also. Plugging means reversing supply. Because the supply is AC in induction motor, I cannot reverse it because it is anyway reversing. So here I am reversing the phase sequence. Basically, plugging means reversing the supply. But here reversing in the sense, I am reversing the direction of RMF by interchanging the phase sequence. So when I apply the brake, what actually is happening in the electric vehicle? The plugging is happening. For a moment, the plugging happens. When plugging happens, the power is regenerated in the rotor. So where it is given? If I don't give it anywhere, it is wasted in the form of heat. But because the braking is continuously in electric vehicle, can I utilize that reverse power flow or regenerated power? So that regenerated power is diverted towards the charging circuit of the battery, and battery gets charged every time when the braking happens. So I am not at all wasting my regenerated power. Instead, I am utilizing it to charge the battery. This is what the smart hybrid vehicles claim of. You know, in market we have smart hybrid vehicles. Smart hybrid in the sense the main engine is either of petrol or diesel. Nowhere it is electric vehicle, but instead the braking is electrically provided because all are now power brakes, right? All are power brakes. Power brakes means what? There is a motor. If you don't turn on the engine, your brakes will not operate. Have you observed in all the cars or anybody who have driven the car? Did you observe this?
Yes.
Steering is locked, brake pedals are locked. Those are not operating because the steering and brake pedals are operated using a motor. Okay. So when the engine is off, there is no power supply to the these motors of steering and brake pedals, braking. Now, whenever I am applying the brake using brake pedal, the power was getting lost. Instead of that, now what they are doing? They are converting it to charge the battery, and that can be utilized for any other application, either for playing the music or whatever the battery operated applications are there in the vehicle can be powered. So this is what they claim it as smart hybrid. In some vehicles, not all smart hybrid vehicles. Okay. Some vehicles are really hybrid vehicles where there is engine and there is a motor. There is an engine drive, there is a motor drive. Okay. So those are hybrid vehicles. Toyota Camry hybrid. That is an actual hybrid car. And if you see the recent one, Maruti Suzuki, what we say, S-Cross, they say that smart hybrid. Okay, so in smart hybrid cars, what they claim is they are utilizing the braking power back to charge the battery. Whereas in actual hybrid vehicle, there is a motor operating. But that power to the motor is given through the engine only. Okay, so if there is a plugged-in hybrid car, then there is a separate battery set which is supplying to the motor, which is actually operating as a main drive system of the vehicle. Okay, so these are various things. Okay. In next semester, if in sixth semester, if I get to take the electric vehicle professional elective, then we will discuss. If I take and if you take, choose that also. Okay. So we'll discuss all those things again. Yeah, coming back to this. So the plugging is mainly the braking. So this is one mode of operation of a motor, induction motor or induction machine. So induction machine is now operated in motor mode. It is now operated in braking mode. The third mode of operation is induction motor as generator. Because to see the overall characteristics of induction motor, these three modes have to be understood. Induction motor as generator. Briefly, in couple of sentences, I have told in the previous classes how a motor can be operated as a generator. Some more things we will look into here. Okay. So, induction motor can be operated as generator by giving external kinetic energy at a speeds above synchronous value. Okay. So if induction motor is run above synchronous speed using external prime mover. This is possible only using external prime mover. Using external prime mover, then it operates as generator. Then it operates as generator. Okay. In that case, what will be the slip? Here, slip will be S is equals to, it is ns minus n divided by ns. Okay. What will be the slip? What will be the slip here? Am I audible?
Yes.
Or did I lose the connection? See, n is greater than ns. Then what will be the slip? Slip will be less than
Negative.
0. Oh, that itself will happen, right? When the rotor speed is greater than the synchronous speed, slip will be negative. Right? Okay. So in generating mode, in generator mode, slip of induction machine is negative. Slip of induction machine is negative. Now, what is the range of the slip? Therefore, for any induction motor, the range of slip is the range of slip is +1 to -1. It is not -1 to +1. Here we should think logically. We should not think mathematically. Whenever I want to express a range of numbers which include positive as well as negative, I generally start from negative and end at positive. Is it? If there are numbers from -3 to 30, I say the range of numbers are -3 to 30. I don't say 30 to -3. That is mathematics. But here we have physics. Even if I want to operate induction machine as a generator, first I have to run it as a motor. So initially when the induction motor is to be operated, it has to be operated in positive slip region. So the first slip, initial slip of the induction motor is positive. When I want to operate it as generator, then final slip of the induction motor machine becomes negative. So the range of the slip is from +1 to -1. Many books they follow it as -1 to +1. Fine, mathematically that is true. But I should understand what is mathematics. It is not only I should speak what is mathematics. Okay. So here the range of slip is for any given induction motor, if it is also operated as induction generator, it is +1 to -1. This is one of the most typical question in many competitive exams on induction machines. The range of slip. Okay. Most of the people will forget that induction motor can be operated as generator also, and they say the range of slip is 0 to 1. Okay. So when it is +1 at standstill, okay, when it is -1, it is ns minus 2ns divided by ns. Okay. Generator, okay, it is as generator at twice the synchronous speed. Now observe this equation. Ns minus n divided by ns, if it has to be -1, then ns minus n should be minus ns. It is ns minus 2ns upon ns is -1. Right? So when what is the now maximum range of speed of the induction motor? Induction motor can be operated at the speeds twice the synchronous value. Yes or no? If the slip range is from +1 to -1, then the speed is from 0 to twice the synchronous speed. But if I have an intention of making induction motor run as induction generator at twice the synchronous speeds, then it has to be decided earlier before the construction only, so that I can provide all the necessary mechanical strength to this machine so that it can withstand the double the synchronous speed value when it is rotating. Okay. Now, how the operation is done? Now, is it that when the induction motor is operated as generator, should I cut off the supply? Now, when induction motor starts operating as generator, should I cut off the supply?
No, sir.
No. Why? Why should I not cut off the supply? Because I need input energy from the supply for rotating magnetic field. If I cut off the supply, then rotating magnetic field is not produced, is it?
Yes, sir.
Yeah. Okay. So we have two powers in a AC network. What are those two powers? Important powers? Yes. Active power and
Reactive power.
reactive power. What active power is doing and what reactive power is doing? Yes. I think now many will leave the class because you may think that I may ask the question. Huh. Ajay Kumar. Ajay Kumar. And when I take anybody's name and if you don't respond, you are absent for the class. Okay. I have done the same thing even in previous classes also. If I take anybody's name and you don't respond, that person will remain absent for that class. I don't give attendance for that. Ajay Kumar, idea? Huh?
Yes, sir.
Yeah. What active power is doing, what reactive power is doing. Bega.
Reactive power controls the flux, sir,
Yeah.
and active power for it helps in torque, sir.
Yeah. Active power is producing the output, power necessary to drive the load. Reactive power is producing the magnetism in the system necessary to create the torque. If all the work has been done by active power, then who will create the torque flux there? So in any electrical system, AC system, remember active power always magnetizes the circuit. Active power always magnetizes the circuit. In every electrical machine, reactive power always magnetizes the circuit. So the magnetization of the system is happening due to reactive power. Okay. But the reactive power requirement for magnetization is very small. If there are excessive reactive power, then I am simply wasting it in the form of copper loss. Because copper losses are occurring in the system not because of the only active current, it is because of the total current. I cos phi plus I sin phi vectorially. That is the current which is creating copper loss. Now, for a minimum value of I cos phi requirement, if I sin phi is very large, unnecessarily I am creating copper losses in the system. Okay. Yeah, coming to this point. Now, when I have an induction motor, when induction motor is operating as induction generator, I will take this as induction generator, okay, which is connected to a prime mover. This is a prime mover giving the rotation to the induction generator. And as a result of this induction generator is giving three-phase supply because now it is generating. Okay, I have a three-phase supply lines here. Say suppose RYB. Okay. So this induction generator is giving the active power P. It is giving the active power P, but it is still receiving the reactive power Q. Okay. So what is total power? In transmission distribution, you know this. S is equals to P plus JQ. Is it? Where S is the total power or apparent power, P is active power, J is reactive power. P is EI cos phi, J is EI sin phi, S is EI. Yes?
Yes, sir.
Did you come across this equation or not?
Yes, sir.
Okay. So the main difference between synchronous generator and induction generator is synchronous generator will generate both active power as well as reactive power. Whereas induction motor will generate only active power but receives reactive power from the external source. Okay, so for an induction generator, we have to supply reactive power externally, either through the supply mains or through the capacitor bank connected across its terminals. Capacitors are the sources of reactive power. Generator, they will generate this reactive power. Capacitors. Power factor improvement topic ಓದಿದ್ದೀರಾ? ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅಲ್ಲಿ ಬಂದು ಹೋಗಿರ್ಬೇಕು ಇಷ್ಟೊತ್ತಿಗೆ ಅದು ಪವರ್ ಜನರೇಷನ್ ಅಲ್ಲೂ ಬಂದಿರುತ್ತೆ ಅದು. ಡಿಡ್ ಯು ಕಮ್ ಅಕ್ರಾಸ್ ಪವರ್ ಫ್ಯಾಕ್ಟರ್ ಇಂಪ್ರೂವ್ಮೆಂಟ್ ಟಾಪಿಕ್? ಓದಿದ್ದೀರಾ ಇಲ್ಲ?
No, sir.
we'll stop here. In the next class, we'll see the further characteristics and we'll move to the next topic. ನೀವು ಎಂಥವ್ರು ಇದ್ದೀರಿ ಅಂತಂದರೆ you people are such a breaking system, you will break the entire enthusiasm of a teacher by not responding to anything. ಇಷ್ಟೆಲ್ಲ ರಿಲೇಟ್ ಮಾಡಿ ಮೋಟರ್ಸನ್ನು ಕಲಿಸೋ ಒಬ್ಬನ ಫ್ಯಾಕಲ್ಟಿನ ಕರ್ಕೊಂಡು ಬರ್ರಿ ನನ್ನ ಮುಂದೆ, ನಾನು ಹೇಳ್ತೇನೆ ನಿಮಗೆ, ನಾನು ಬಿಟ್ಟೇ ಬಿಡ್ತೀನಿ. ಐ ವಿಲ್ ಡ್ರಾಪ್ ದಿಸ್ ಪ್ರೊಫೆಷನ್ ಓನ್ಲಿ. ನೀವು ನಾಲಾಯ್ಕಿದ್ದೀರಾ ನೀವು ಕಲಿಯೋದಕ್ಕೆ. You people find it hard even to respond to say yes or no. Okay, in the next class we will see the overall characteristics. Now you know what is generation. Okay, and then we will move to losses and efficiency.